Yes, sir.
So you have, as shown in the figure, a network or resistor is connected to a 24-volt battery with an internal resistance of 3 ohm. So the battery has internal resistance of 3 ohm. The currents through the resistors are R4 and R5 are I4 and I5 respectively. The values of I4 and I5 are. So you have to find out the value of I4 and I5. That's what you have to find. So let's see. Okay, so what will be the equivalent resistance of the circuit? The equivalent resistance of this 2 ohm and 2 ohm would be 1 ohm. This equivalent resistance would be 1 ohm. This is your 2 ohm resistance. And the equivalent of this 20 ohm and 5 ohm. So what should be the equivalent of this 20 and 5? So you get 20 times 5 over 20 plus 5. That is, you have 100 over 25, and hence 4 ohm is the equivalent resistance of this. Now the total equivalent of the circuit will be 1. R total is going to be 1 ohm plus 2 ohm plus 4 ohm plus 2 ohm and plus the internal resistance, that is 3 ohm. So this is the total resistance of the circuit. You can get 3 plus 2, 5, 5, 5, 10 and 12 ohm. So 12 ohm is the total resistance of the circuit, right? So in this way, I can get the current also. What should be the total current drawn from the battery?
Two ampere.
Yes, what will be the total current drawn from the battery?
Sir, is it 2 ampere?
Yeah, so total current would be 2 ampere. We know here the total current as 2 ampere. Now we want to find out what will be the current here, I4 and I5. This is the total current, and I want the current I4 and I5. So if I know the total current across a parallel combination, so how do I find out the current through across each resistor? So current across each resistor, like if I want to find out the current across this R4, so I4 would be given by R5 divided over R4 plus R5 multiplied with total current I. Right? So this is a shortcut. You can use this. This shortcut has been obtained by using KVL. So by using the Kirchhoff law, you can obtain this shortcut. So by this method, you will be able to obtain the total current that is being connected or that is passing through R4. Okay. So to find the current through R4, you have to multiply it by the opposite resistance, the remaining resistance in the parallel combination. So suppose if there are 3, so you will be multiplying the remaining of this 2. So now there are 2 resistances. You will multiply the total current by the resistance R5 and divided by the sum of the resistances. So here the sum of the resistances are R4 and R5. Got it? So the equivalent, the current I4 would be given by R5 is 5. So you get 5 divided by R4 plus R5, so 25, and multiply by R, which is 2. So you get 10 by 25, which is 0.4 ampere as the total current passing through I4. In the similar way, I can find the current I5. So the current I5 will be given by the resistance R4. It would be the resistance R4 divided by R4 plus R5 and multiplied by the total current. So you can keep a note of this formula. You can use this to find out the current through the parallel combination. So here, if you know the total current, I know the total current that's passing is 2 ampere. So now I can get it. So R4 is R4 is 20. So you get 20 divided by 25 and multiply by 2. So you have 5, 4 times 20, 5 times, so 8 over 5. And 8 over 5, if you divide, you are getting 1.6, right? 1.6 ampere. So if you add them, you get your 2 ampere C. So you could also obtain if one of the resistance, if one of the current through one of the resistance is 0.4, so current through the other would be 2 minus 0.4, that's 1.6. So now you can check the answer. Here you have the options 8 by 5, 2 by 5. Okay, so this is correct one. 8 by 5 and 2 by 5. That is the first option is the correct one. Okay, Srita. And okay, Srita and Javier. Thank you. So have you understood this question?
Yes, sir.
Yes. Now see, a hollow cylindrical conductor has length 3.14 meter, while its inner and outer diameters are 4 meter and 4 mm and 8 mm respectively. The resistance of the conductor is n multiply 10 to the power minus 3, and hence you have to find the resistance. So as we know that the resistance R is given by rho L by A. Also, resistivity is given to you. So can you use the formula?
Yes, sir.
So here we will have R equals rho L by A. So you need to find out area. So how you will get the area here? See, the more quickly you are able to get, area of cross section will be given by pi R2 squared minus pi R1 squared. Okay. So taking out pi common, you have R2 squared minus R1 squared. The value of R2 is 4 mm. The diameter is the outer diameter is 8 mm. So radius would be 4 mm. So you will get here 4 multiplied 10 to the power minus 3 whole squared and minus R1 squared, which is radius is 2. So you get 2 multiplied 10 to the power minus 3 whole squared. And hence you will get area as pi multiply 16 multiplied 10 to the power minus 6 minus 4 multiplied 10 to the power minus 6. You can take out 10 to the power minus 6 common. So you have pi multiplied 10 to the power minus 6. And 16 minus 4 would be 8. So you get multiply 8. So this is the area. Now you can put the value and obtain the value of resistance. So can you tell me what will be the value of resistance?
Yes, sir.
Yeah. So try to calculate. Be quick in your calculations. R is 2.4, rho is 2.4 multiplied 10 to the power minus 8. Multiply by length, which is 3.14, divided by area, which is 3.14 times 8 times 10 to the power minus 6. Okay. So you have 3.14, 3.14 cancelling, 10 to the power minus 6 and 10 to the power minus 8. So you will be left with just minus 2. And you can have 2.4 by 8 multiplied 10 to the power minus 2. You will get here 0.3 multiplied 10 to the power minus 3 minus 2. Sorry, these are minus 2. And you get 3 multiplied 10 to the power minus 3. So what should be the answer? What should be the resistance here? The value of N is
3.
3. See, the question will you just need to practice the questions. Also, I'll be sending today's question also and some questions from electromagnetic induction. Do practice them. And tomorrow I want to do ray optics. Okay. So basically there are certain questions from ray optics. So I want to do ray optics today and tomorrow. I request all of you to practice current electricity and questions from electromagnetic induction. See, a cell of
Okay, sir.
EMF 90 volt is connected across series combination of two resistors, each of 100 ohm resistance, and a voltmeter of resistance 400 ohm is used to measure the potential difference across each resistor. The reading of the voltmeter will be. So I think these are simple questions and you can find out them. Okay, you just need to practice them. So can we start with electromagnetic induction or shall we continue these questions?
Sir, you can start with electromagnetic induction.
Yeah, so I think it would be
Yes,
better
sir.
if you see some questions from electromagnetic induction also. Okay. Uh, Okay, so just let me share the screen. Yeah. Okay, so I hope the screen is visible. Just go through this
Yes, sir,
first
it is.
question. Yeah, go
Yes.
through the first question and just tell me the concept how you will be doing. Tell me the concept. If you are aware, then we can skip and move to the next question. Okay, so have you gone through the question? A conducting loop of radius 10 over under root pi centimeter is placed perpendicular to a uniform magnetic field of 0.5 Tesla. The magnetic field is decreased to 0 in 0.5 seconds at a steady rate. The induced EMF in the circular loop at 0.25 second is. Okay, so what concept is to be utilized here?
EMF is equal to d phi by dt.
Yeah, so EMF is equal to d phi by dt. We'll be utilizing E equals to d phi by dt, and phi will write as b by a, b times a. We know that b is constant, but okay, b is changing, but area is constant. So we'll keep it area over here and d b by dt, rate of change of magnetic field with respect to time. Now, what is the change of magnetic field? It says that a uniform magnetic field is 0.5 Tesla. The magnetic field is decreased to 0 in 0.5 seconds at a steady rate. So the induced EMF in the circular loop at 0.25 seconds. So see here it has given for a time period t of 0.5 second, the magnetic field has decreased from 0.5 Tesla to 0, right? So you have to find what would be the magnetic field at t equals to 0.25 seconds. Okay. So what would be the value of dB? dt we know. Area you can find out. Area you can find out here. Area will be pi r squared. So area would be pi times of 10 squared by pi, and dB is the rate of change of magnetic field. So here dt is 0.25 and the change of magnetic field. The change of magnetic field would be again 0.5 by 2. It would be still 0.25. हेलो चलना है भैया मतलब yes. So see, the rate of the flux remains the same. You observe the rate of change of flux since the flux is brought at a uniform rate. So if you even if you take it for 0.25 seconds or you take it for 0.5 seconds, the rate of change of flux is the same. Okay. So this would cancel out. It would remain 1, and we get the formula here as 100. So it's 100, but this was in centimeter. See, the radius was in centimeter. If you convert this centimeter to meter, you will get multiply 10 to the power minus 2 whole squared. So you'll get 100 multiply 10 to the power minus 4, and hence you can write it as 10 minus 3, which is 10 millivolt. So what answer should be there? Yes, what should be the answer here? Are you all there? Sriyuta?
Option 2.
Yeah, option 2 should be there. And here we okay. So here what happens? We if you are decreasing the magnetic field at a constant rate. So if you find it for 0.25 second or 0.5 second, the induced EMF would remain the same. Okay, because it's constant. The rate of change of flux is a constant. Now see this one. A metallic rod of length L is rotated with an angular speed of omega, normal to a uniform magnetic field B, about an axis passing through one end of the rod, as shown in figure. The induced EMF will be. So what should we utilize here? Yes. Any idea? Okay. What is changing here? Is there changing magnetic field or uh, is there changing area? We observe here that in this question, so here you observe that a metallic rod of length L is rotated at angular speed omega normal to the uniform magnetic field. Since the magnetic field is uniform, so there will not be any change of the magnetic field. What we have to find is just change of area. So we can write E is equal to B times of dA by dt. The area can be written as, we can write the area to be, okay, what would be the area swept by this? If it is rotating with an angular speed omega and it has the radius r, so how we'll find out the area swept by it? Area swept by it time t. Yes. Yes, Javian and Sriyuta, any idea how we'll find the change of area? See, it is sweeping out area. So you need to find out what will be the area covered. Radius and how much area is it covering in a given time.
Sir, I'm not sure.
Yes. Okay, not sure of how to find out the area. Any Javian, how to find out the area?
Not sure, sir. Prime.
Okay, let's see. Okay, see, suppose it has, okay, it's rotating like this. So suppose it is over here after covering an angle theta, it is at this point after some time t. So after some time t or dt will be taking. After some time t, it has traveled an angle of theta. So I can find out this angular velocity. Its angular velocity omega will be given by d theta by dt. This we know that angular velocity is given by d theta by dt. And what is the area covered? How we will find out this area? See, have you studied about the area of sector? Okay, area of circle. Area of circle is given by pi r squared, right? And we know during this uh, pi r square is the area of complete circle where the angle subtended by the arc is equal to 2 pi. So the angle here has reduced to pi. Therefore, here, uh, if we have angle covered as theta, so area would be given by theta by 2 r squared. I will let area as theta by 2 r squared. So did you understood how did we get the area here? From the formula of area of circle, we know that area of circle is pi r squared. Okay. Also, if you have studied earlier, so you get theta over 360 by pi r squared, that's the area of sector. Here we are using in radian. So in radian, we observe that when the angle is complete 2 pi, you are getting area as pi r squared. So every time you will be getting the angle as half. So here area would be theta by 2 r squared. Now I can write here, I can write this area as d by dt of theta by 2, and instead of r I will write here L. So it is L square. Now I'll get it as BL squared by 2 and here dt. So what is the value of d theta by dt? Omega. D theta by dt is equal to omega. So I get here BL squared omega by 2. Okay. So this is our option number 3. 1 by 2 BL squared omega. Got it? So you added one concept here
Okay,
that
sir.
to find out the area of sector. Okay. So if you are finding the area of sector is given by This is the new thing that you have got. Area of sector will be given by theta by 2 r squared. Okay. It's theta by 2 r squared or theta by 2 l squared. This is a new formula. You can keep a track of it. And it's the same as pi r squared. No differences. Okay. So let's move to the next one. A wire of length 1 meter moving with velocity 8 meter per second at right angles, magnetic field of 2 Tesla. The magnitude of induced EMF between the ends of the wire will be. Okay. So let's see. You have a wire of length L, length 1 meter. You are given length equals to 1 meter and it is moving with a velocity of 8 meter per second. Magnitude of magnetic field is given as 2 Tesla. You have to find the magnitude of the induced EMF between the ends of the wire. So here, when the wire is moving through the magnetic field like this, so the charges in the wire, they will experience a force. So the positive charges will move to one end and the negative charges will move to the other end, and hence there will be an induced EMF. So this is an motional EMF. This is an example of motional EMF or induced EMF. Okay. So using this, now I can find this out as induced EMF will be equal to d phi by dt. Since the magnitude of magnetic field is constant, so I will put here B as constant and dA by dt. So the area swept by this length is L, and suppose it travels a distance x here. So the area swept will be given by L multiply x. I can write it as B times of L multiply x, and here you have d phi by dt. So you can write B L multiply by dx by dt, which is your velocity. So just add the value BLV. So B is 2 multiply length, that is 1 meter, multiply velocity, which is 8. So 8 2 it's 16. So your correct answer is option 4. It will be 16 volts. There will be an induced EMF of 16 volt. Okay. You have earlier learned also the formula induced EMF is given by BLV. The motional EMF is given by BLV. Right? So this is the induced EMF or motional EMF. So I think now you should try the next one. I'm giving you just 2-3 minutes try out, then I will explain this. I'll be sending these 2 assignments in your group also for a practice. A certain elastic conducting material is stretched into a circular loop. It is placed with its plane perpendicular to a uniform magnetic field, V equals to 0.8 Tesla. When released, the radius of the loop starts shrinking at a constant rate of 2 centimeters of constant rate of per 2 centimeter. Yes, very simple. Just use the formula E equals d phi by dt. Okay, so E is d phi by dt. Phi will be written as B multiply A. Since it's a circular loop, So we will use the formula of circle as pi r squared. So we'll write d by dt of b multiply pi r squared. So b is a constant, r is changing, r is not a constant. So now we'll write here pi multiply b, and you have here d by dt of r squared. So the radius shrinks at a rate of 2 per centimeter. Now you differentiate this, you get pi b multiplied 2r, right? So this is what we get, pi b multiplied 2r. And here you have dr by dt. Since here it's r, so we'll also include dr by dt, and now we can just put the value here. The value of, we can put pi multiply b, which is 0.8, multiply 2, multiply r. So r is given as the induced in the loop at an instant when the radius of the loop is 10 centimeter. So we put the value of r as 10 centimeter, which is 0.1. So put it 0.1 and multiply dr by dt. So the dr by dt, rate of change of radius with respect to time, is 2 per centimeter. So you put here 2, and I think you will be getting the answer. So 2 multiply 2 will be make it 4. 4 multiply 8 will become 32, and you get 0.32 multiply pi. Pi is 3.14. So what answer we will get here? We will get 0.32 multiply 3.14. You get 1 as the answer. Okay. So should the answer be 1, or it should be something else?
Yes, sir.
No. Now you have to make the corrections. Here we have taken r in centimeter. See, at every point we have taken r here in centimeter. So this will we shall consolidate this by using r in meter. So if you convert this r from centimeter to meter, so you'll put everywhere as 10 to the power minus 2, and hence utilize, do it again, obtain your answer in millivolt. So you will get your answer here somewhere, whatever answer you get. So I'm sending you the PDF after the class. Just now you can do some questions from here. Tomorrow we'll have class on ray optics, and I think tomorrow you have the last class.
I think so, sir. I'm not sure.
Yeah, maybe tomorrow we have the
Then
last.
I'm not sure.
Yeah, tomorrow I think is the last class. So you can check if you have any doubts, you can clarify tomorrow. And from the ray optics also we'll be doing tomorrow. Okay,
Okay,
bye
sir.
all of you.
Thank you, sir.
Thank you.